All rise for the Honorable Judge Sam. The Court of Calculus is now in session.
The question for the court today is, did Dade and Gustavo rob the Pyramid of Toby? Derivative attorney, what's your opening statement?
Your Honor, the prosecution has video evidence from the closed-circuit camera system in the pyramid of the defendant stealing this painting.
Intriguing. Defense, what's your response?
Your Honor, my clients could have not stolen the priceless painting from the Pyramid of Toby. This is because the safety mechanism of the pyramid with the sand was falling at 100 cubic meters per second. The prosecution claims that my clients could have escaped from the door halfway up the pyramid, but this is not possible because the sand was filling up too quickly.
Derivative attorney, what's your response?
Your Honor, the defense has claimed that the pyramid refilling the sand too fast for the robbers to escape. This is false. We know that the height of the pyramid is 120 meters, and it has a square base that is 40 meters by 40 meters, and is filling the sand at a rate of 100 cubic meters per second. Additionally, we know that there's an exit 30 meters from the top of the pyramid. So first, we will find how long it would be before the sand reached the exit. So we know the formula for the volume of the sand is the volume of the pyramid minus the volume of the air remaining in the pyramid. And the formula for volume of a pyramid is 1/3 length times width times height. And since this is a pyramid with a square base, we know that length will always equal width. So that means we can simplify it and just be 1/3 width squared times the height. So we can substitute in our values for the whole pyramid in here. But then we need to find what the width would be here when the height of the air is 30. So for that, we can use similar triangles, and we'll set up this proportion, which is 120 over 40 equals 30 over W. We will then solve that for W, so we can find that the width will equal 10 when the height is 30. So we substitute those values into our equation here, and we find the volume of the sand when the sand reaches the door is 63,000 cubic meters. And to find how long it would take, we will multiply that value by the rate at which the pyramid is filling the sand, which is 100 cubic meters per second. So we multiply those together and we can cancel the cubic meters, and we find that it would take 630 seconds or 10.5 minutes. So that means from the time at which they stole the painting, which activated the sensors, they would then have 10.5 minutes to get to the exit. Next, we'll find how fast the depth of the sand would be changing when the sand reaches the exit. So to find that, we will again use our formula for the volume of the sand, which is the volume of the entire pyramid minus the volume of the air. We know that the volume of the entire pyramid is 64,000, and then we need to subtract the volume of the air. So for that one, since the volume of the air will always be changing, we cannot yet substitute in specific values for the volume of the air. So we need to find a general equation for the volume of the air, and we want to get it in terms of the depth, of the height, and we'll call the depth of the sand G. And we need to find the change in the depth with respect to time, which will be dg dt. So we want to get a formula for the volume of the air in terms of the height. So to do that, we'll again use our similar triangles, and instead of using specific values, we'll just leave them as h and w. So we will set up this proportion again, and we will find that the width will always equal 1/3 of the height. We will substitute that into our equation for the volume, and simplify it to find that 127 h cubed is the volume. So we can then use that here for the volume of the air. So we're going to have the volume of the entire pyramid, which is 64,000, minus 127 of the height of the air. The height of the air is going to equal 120, the height of the whole pyramid, minus g, which is the depth of the sand. So we have that cubed for our formula for the volume of the sand. We will then take the derivative of this equation with respect to time. So then we have dv dt equals negative 127 times 3 times 120 minus g squared times negative 1 times dg dt. We simplify that, and then we can substitute in 100 cubic meters per second for dv dt, since dv dt represents the change in the volume of the sand with respect to time. So we substitute in 100, and we solve for dg dt, and we find that it equals, we also substitute in what g would be when the sand reaches the exit, and that would be 90, so we substitute that in, and we solve for dg dt, and we find that equals 1. So we have 1 meter per second. So that means when the sand reaches the doorway, the depth will be changing at 1 meter per second. That means that since the standard doorway is 2 meters high, they would have 2 seconds to exit the doorway once the height of the sand reached the door. Therefore, Your Honor, through my mathematical calculations, I have removed any doubt that the thieves could have stolen the painting and then escaped. First, I proved that once the pyramids began to fill with sand, the thieves would have had 10.5 minutes to reach the exit. Furthermore, the change in the depth of the sand was only 1 meter per second once it reached the exit, which means that there is no doubt that the thieves could have stolen the painting and then escaped through this exit.
Now that we've seen all the evidence, let's see what the jury decides.
The jury has decided on guilty.
The verdict is guilty.